Long before agriculture, before permanent settlements, and long before written language, human survival depended on relationships. Not as a secondary advantage, but as a fundamental evolutionary strategy. In unstable prehistoric environments, physical strength alone was insufficient. What separated humans from extinction was their capacity to form enduring social bonds, coordinate behavior, and adapt collectively to a constantly changing world. During the late Pleistocene, roughly between 300,000 and 12,000 years ago, multiple human populations occupied vast and diverse landscapes. Homo sapiens emerged in Africa and gradually expanded into Eurasia, encountering other hominin groups such as Neanderthals and Denisovans. These populations faced extreme climatic fluctuations. Glacial cycles reshaped ecosystems. Rainfall patterns shifted. Entire regions oscillated between abundance and scarcity within a few generations. In this context, isolation was one of the greatest threats. Small, mobile groups formed the basic unit of survival. These were not random gatherings. They were structured social systems shaped by kinship, familiarity, and repeated interaction. Group size was constrained by ecological limits, yet large enough to allow cooperation, division of labor, and social learning. Each individual occupied a role, whether as hunter, forager, toolmaker, caregiver, or knowledge holder. Before we dive in, tell us where you're watching from and subscribe if you're enjoying Primal Roots. Archaeological evidence demonstrates that cooperation extended far beyond immediate necessity. Fossil remains from multiple sites reveal individuals who survived severe trauma, chronic illness, or congenital conditions. Fractures healed improperly, teeth lost long before death, degenerative joint disease in advanced age. These individuals could not hunt or forage efficiently. Their survival implies long-term care, consistent food sharing, and protection from predators and environmental stress. Such care required planning and emotional investment. It reduced short-term efficiency but increased long-term group stability. Knowledge accumulated rather than being lost with each death. Skills were transmitted across generations. Social memory expanded. Groups became more resilient, capable of adapting to environmental change through experience rather than trial and error. Pair bonding further strengthened these systems. While prehistoric mating patterns were flexible, genetic and ethnographic data suggest relatively stable reproductive partnerships. Cooperative parenting reduced infant mortality and allowed longer developmental periods. Human infants are born neurologically immature and require years of sustained care. This dependency created strong selective pressure for social tolerance, emotional regulation, and shared responsibility. Extended childhood was not a weakness, it was an evolutionary advantage. Longer learning periods allowed the development of complex skills, communication, and social awareness. Children learned not only how to survive, but how to belong. Social norms, behavioral expectations, and cultural practices were internalized early, reinforcing group cohesion. Social relationships extended beyond immediate family. Archaeological materials reveal long-distance exchange networks spanning hundreds of kilometers. Obsidian, shells, pigments, and stone tools moved far beyond their natural sources. These materials did not travel alone. They moved through social connections, repeated contact, and mutual trust between groups. Such exchanges reduced risk. When one region experienced scarcity, connections provided alternatives. Information about resources, migration routes, and seasonal patterns circulated through these networks. Innovation spread faster. Technological advances did not remain isolated. They became shared solutions to shared problems. Adaptation was therefore not only biological or technological, it was social. Groups that maintained broader social networks were more flexible. They could absorb environmental shocks more effectively. Social connectivity became a buffer against extinction. By the Middle to Late Paleolithic, human social systems displayed a level of complexity unmatched among other species. Cooperation was no longer situational. It was embedded in social expectations, roles, and shared behaviors. Norms regulated access to resources. Reciprocity structured interactions. Trust reduced internal conflict and allowed coordination at larger scales. These systems favored individuals with advanced social cognition. Understanding intentions, anticipating behavior, and maintaining relationships became critical survival skills. Over time, natural selection favored emotional sensitivity, communication ability, and behavioral flexibility. Social intelligence became as important as physical adaptation. This transformation marked a turning point in human evolution. Survival was no longer achieved solely through individual strength or speed. It depended on belonging, coordination, and shared purpose. Relationships became adaptive systems, shaped by environmental pressure and refined over thousands of generations. The archaeological record makes this clear. Early humans were not merely reacting to danger, they were actively shaping their social world. They invested in others. They planned for the future. They created systems that outlasted individuals and stabilized populations across unstable landscapes. This is the foundation of the human story. Before symbolism, before art, before complex language, there was social structure. There was care. There was cooperation sustained by emotional bonds and collective memory. Beyond survival, prehistoric humans were already building something more durable. They were building society. As human social systems stabilized, relationships expanded beyond coordination and shared labor. Emotional bonds became a central adaptive force, shaping behavior, cognition, and long-term survival. These bonds were not abstract concepts. They were enacted daily through care, attachment, trust, and shared experience, leaving measurable traces in the archaeological and fossil record. One of the strongest indicators of emotional investment is long-term care for non-productive individuals. Across Africa, Europe, and Western Asia, skeletal remains show repeated patterns of survival after serious injury or illness. Individuals lived for years, sometimes decades, with impairments that would have made independent survival impossible. This required sustained food provisioning, physical protection, and social tolerance. Paleoanthropologist Erik Trinkaus documented these patterns extensively in Neanderthal populations, demonstrating that healed trauma and chronic conditions were common rather than exceptional. These findings overturned earlier assumptions of purely brutal prehistoric life. Instead, they reveal social systems capable of maintaining care over long periods, even under harsh environmental conditions. Care reshaped group dynamics. Food sharing became regulated by social rules rather than immediate contribution. Risk was redistributed collectively. Emotional attachment reinforced trust and reduced internal competition. These mechanisms increased group cohesion and lowered the likelihood of fragmentation during times of stress. Such bonds also transformed reproductive strategies. Human offspring are unusually dependent, requiring years of continuous care. This biological reality exerted strong selective pressure for emotional stability, patience, and cooperation. Parenting became a shared enterprise, extending beyond biological parents to siblings, grandparents, and unrelated group members. Anthropological models describe this system as cooperative breeding. It allowed mothers to invest more energy in fewer offspring while increasing overall survival rates. In parallel, extended childhood enabled prolonged brain development. Neuroplasticity remained high for longer periods, supporting complex learning, social calibration, and cultural transmission. Emotional bonds were therefore directly linked to cognitive evolution. Learning did not occur in isolation. It was embedded in relationships. Children learned through observation, imitation, and guided participation. Emotional security created the conditions for curiosity and exploration. Knowledge accumulated across generations rather than being lost. As emotional systems matured, symbolic behavior emerged as a new layer of social cohesion. Intentional burials mark a critical threshold. Bodies were placed deliberately, often in specific positions, sometimes accompanied by tools, pigments, or ornaments.
These practices required time, coordination, and collective participation. They offered no immediate survival benefit. The meaning of burial lies not in speculation, but in behavior. It reflects recognition of individual identity, memory, and group continuity. Death became a social event, managed collectively. Emotional bonds extended beyond life, reinforcing group cohesion through shared ritual. Ochre use provides further insight.
Found in habitation sites, burials, and symbolic contexts across Africa and Eurasia, ochre was consistently selected, transported, and processed. Its repeated application suggests shared meaning, possibly related to identity, status, or ritual expression. Symbolism created a common language of belonging. Cave art represents another leap in emotional and cognitive complexity. From the caves of Chauvet and Lascaux to sites in Indonesia and Iberia, similar motifs appear across vast distances. These images required planning, cooperation, and technical skill. They were produced in spaces that demanded effort to access, often deep within cave systems. Art functioned as collective memory. It encoded information about animals, environments, and social values. It reinforced emotional bonds through shared narratives and visual symbols. Participation in these practices strengthened identity and continuity across generations. Language amplified these processes. While speech leaves no direct fossil record, anatomical evidence from the hyoid bone, auditory structures, and neural organization supports advanced vocal communication by at least 100,000 years ago. Genetic studies involving the FOXP2 gene further reinforce this timeline. Language allowed precise emotional expression. It enabled storytelling, instruction, negotiation, and the transmission of social norms. Shared language intensified bonding by aligning emotional states and expectations. It reduced conflict by allowing explanation and reconciliation. It strengthened cooperation by enabling planning beyond the immediate present. British anthropologist Robin Dunbar proposed that increasing social group size drove the expansion of the human neocortex. According to the social brain hypothesis, managing complex emotional relationships required enhanced cognitive capacity. Emotional intelligence became a survival trait. Understanding others' intentions, maintaining alliances, and navigating social hierarchies increased reproductive success. Emotions also regulated behavior internally. Empathy reduced aggression. Shame and guilt discouraged actions that threatened group stability. Trust facilitated cooperation without constant enforcement. These mechanisms reduced the energetic cost of social living and allowed groups to scale in size and complexity. Importantly, emotional bonds extended between groups. Exchange networks were not merely economic systems. They were social contracts reinforced by trust, reciprocity, and shared ritual practices. These intergroup relationships reduced isolation and allowed rapid diffusion of technology, genes, and cultural innovations. As climatic instability intensified toward the end of the Pleistocene, emotionally bonded networks became critical buffers, Groups with broader social connections adapted more effectively to environmental change. Emotional resilience translated into demographic resilience. By the Upper Paleolithic, human societies were fully embedded in emotional and symbolic systems. Relationships structured movement patterns, settlement choices, and subsistence strategies. Identity influenced survival decisions as much as ecological knowledge. The scientific record converges on a clear conclusion. Emotional bonds were not secondary outcomes of intelligence. They were drivers of it. Care, attachment, and shared meaning transformed fragile populations into interconnected systems capable of long-term persistence. Prehistoric humans were not defined solely by tools or fire. They were defined by their capacity to care, to remember, and to assign meaning to existence. These emotional architectures laid the groundwork for morality, culture, and the complex social institutions that would later define civilization. Long before cities or agriculture, humanity crossed a decisive threshold. Survival alone was no longer enough. Relationships had become the framework of human life. As prehistoric human societies expanded across continents, survival increasingly depended on relationships beyond the boundaries of a single group. Intergroup connections became a defining feature of human adaptation. These relationships transformed isolated populations into dynamic networks, capable of sharing resources, information, and resilience across vast and unstable landscapes. By the late Pleistocene, Homo sapiens occupied environments ranging from tropical forests and coastal zones to arid deserts and glacial margins. Each region imposed distinct ecological pressures. No single group possessed all the knowledge required to survive every fluctuation. Intergroup contact allowed solutions to spread faster than genetic adaptation alone ever could. Archaeological evidence demonstrates that these connections were sustained and intentional. Raw materials such as obsidian, marine shells, and pigments appear hundreds of kilometers from their geological origins. These materials moved through repeated exchanges, not random displacement. Such movement implies trust, reciprocity, and social obligation maintained over time. Exchange networks served multiple functions. They reduced the risk of local resource failure. They facilitated access to rare materials. They also acted as conduits for technological innovation. Tool-making techniques, hunting strategies, and subsistence knowledge circulated between groups, accelerating cultural evolution. These networks were not purely economic. They were social systems governed by norms and expectations. Reciprocity regulated access. Reputation mattered. Groups that violated trust risked exclusion, a severe penalty in unpredictable environments. Cooperation between groups required emotional regulation, conflict management, and shared symbolic frameworks. Intergroup relationships also influenced mobility. Seasonal aggregation sites, where multiple groups gathered periodically, provided opportunities for mate exchange, alliance formation, and information sharing. These gatherings reduced inbreeding and increased genetic diversity, strengthening population health and adaptability. Genetic evidence confirms this pattern. Ancient DNA reveals repeated episodes of gene flow between populations, including interactions with Neanderthals and Denisovans. These encounters were not isolated events. They were embedded in broader patterns of contact and coexistence. Gene flow introduced adaptive traits, such as immune responses and physiological adaptations to new environments. Social flexibility allowed humans to absorb and integrate diversity. Cultural boundaries were permeable. Knowledge was shared selectively but consistently. This openness enhanced survival during periods of rapid environmental change. Climate instability intensified toward the end of the Pleistocene. Abrupt warming and cooling events reshaped ecosystems within decades. Large animals disappeared. Plant distributions shifted. Groups that relied solely on local knowledge faced extinction. Those embedded in broader social networks adapted more effectively. Social complexity functioned as an ecological buffer. When one region failed, others compensated. Information about migration routes, seasonal cycles, and resource availability flowed through social ties. This collective intelligence reduced uncertainty and improved decision-making. Cognitive demands increased accordingly. Managing intergroup relationships required advanced social perception, memory, and emotional control. Individuals needed to track alliances, recognize outsiders, and navigate unfamiliar social contexts. These pressures favored further expansion of cognitive capacity. Language played a critical role. Shared linguistic frameworks facilitated negotiation, storytelling, and the transmission of norms across group boundaries. Even partial mutual intelligibility supported cooperation. Language aligned expectations and reduced misunderstandings, increasing the efficiency of collective action. Symbolic behavior further stabilized these networks. Shared motifs, rituals, and material culture created recognizable identities. Symbols acted as social signals, communicating affiliation and intent. They reduced uncertainty during encounters and reinforced trust between groups. As populations grew and networks expanded, human societies crossed a threshold. Adaptation was no longer primarily genetic or individual. It became collective and cultural. Knowledge accumulated at a pace unmatched by biological evolution. Each generation inherited not only genes, but a vast repository of shared solutions. This shift produced a decisive evolutionary advantage. Humans became capable of occupying nearly every terrestrial environment on Earth. From Arctic tundra to equatorial rainforests, survival depended less on physical specialization and more on social coordination. The archaeological record reflects this transformation. Toolkits diversified. Settlement patterns became more flexible. Subsistence strategies combined hunting, gathering, fishing, and foraging in adaptive mosaics. Social networks underpinned every aspect of this success. Importantly, social complexity also reshaped human behavior internally. Norms regulated aggression. Cooperation replaced constant competition. Conflict resolution mechanisms reduced group fragmentation. Emotional bonds extended beyond kinship to include allies and trading partners. These systems required energy and maintenance, but their benefits outweighed their costs. Groups embedded in dense social networks exhibited higher resilience, faster recovery from disruption, and greater long-term persistence. By the transition to the Holocene, the foundations of modern human society were firmly in place. Agriculture, sedentism, and complex institutions would emerge later, but they did not create social complexity. They built upon it. The prehistoric world was not defined solely by danger and scarcity. It was defined by connection. Human success was not the result of solitary brilliance or physical dominance. It was the product of shared knowledge, emotional bonds, and cooperative adaptation across generations. Beyond survival, prehistoric relationships formed the architecture of humanity. They transformed vulnerable populations into a global species. They turned uncertainty into opportunity. They allowed humans not only to endure, but to reshape the planet itself. This is the lasting legacy of prehistoric relationships. Long before history was written, humans had already mastered the most powerful technology of all, the ability to live, adapt, and thrive together. Understanding human evolution means understanding relationships. Subscribe for evidence-based documentaries that reveal how science explains who we are and how we became human.